Hello, guys. Um, so next we'll talk about some important UI features or elements before getting into testing and persistent data, which are the next topics on the schedule or the list. So you remember we started our Hello World or the Greetings app with a constraint layout, but then quickly moved to the linear layout, right? Because it was easier to talk about in the beginning. But constraint layouts have certain advantages over linear layouts and all other types of layouts. Um, so we'll now talk briefly about constraint layouts. I'll show a few things in the live code, and then you should be able to use them for future assignments. And then drawables. So drawables is another feature of Android where you can use the XML code to specify vector graphics in a way. And we'll use it on our Dice Games app to not just show the numbers, but show what an actual die should look like. So we'll draw those dots and we'll try to create that. So first of all, here are the recommended reading resources, all of them from Android Developer Guide. So layouts, they talk about declaring layouts over here. Then there is a nice page including a couple of videos from the Google people um, about building a responsive UI with constrained layout. And you have some resources on drawables, of course. Okay, so um, yeah, I'm drawing from these particular pages and adapting it for our apps. All right. So first of all, you know, what is happening behind the screens when you create a layout, either through XML or through Java code. So there are these two types in Android, view group and view, um, which essentially show us what we want to look at, right? So view groups, they translate to the layouts. And as you can see from this hierarchical picture, they can have children, which themselves can be view groups or views. And views then can be things like the buttons or edit text box or any of those individual widgets that the user interacts with. Okay. What happens when you create a linear layout? So you can perhaps map this to an imaginary linear layout like the ones we have created. This view group here is um, the root linear layout, which has first child as another linear layout, second child as, say, a button, and then third child as another linear layout, right? The first child linear layout in turn has two children, again, let's say linear layouts because, well, they could be one of them is horizontal, the other is vertical, or something like that. So you need to separate them out because, a given linear layout can only handle horizontal or vertical placements, and then they have their own children. So you'll notice all the leaf nodes of this tree representation are going to be views, that is the individual widgets which cannot have children inside them. Understand, right? um, so this is a picture, right? So, and then think about how you access the buttons, etc. in the Java code. You simply call find view by ID. What that tells us is um, um, the Android system has a way of flattening this hierarchy and being able to extract an individual view um, from that flattened hierarchy, right? By the way, view is an actual class, and text view, for example, derives from it, and then button derives from text view, and so on, right? So yeah, so a lot of juggling is happening behind the screens where this hierarchy is flattened uh, and the widgets are placed based on several attributes you specify. Um, Pros and cons, linear layout, as we have seen, you can start building pretty easily um, from the scratch elements. And the cons is flattening this is difficult. One, difficult as in less efficient for the system. um, and the deeper the hierarchy, more time it will take to just do just that, just to render things on the screen, and also to grab the widgets in your Java or Kotlin code. Um, Another aspect is it is also not very easy to develop UIs once you are practiced or seasoned with these things. So to move an element from, say, the left subtree here to the right subtree over here, um, you have to make sure it goes in a proper um, hierarchy, and you cannot simply drag and place it on the screen, right? So that's the other negative side of it. So constraint layout, it creates a flat um, layout. It's a flattened, already flattened way. There are no hierarchies. There are no view groups, under view groups um, required, unless, of course, you want to specify that. So you will find just one constraint layout root element, and inside that you just place your widgets and specify them with respect to relative location from some other widget, or say the parent or the boundaries. So that's how it works. Now, doing that, to start doing that is not easy, as in, you need to play around, you need to get a sense of where this widget is going to be on the screen, um, what attribute, what sort of weight, margin, or location it should have on the screen. So that part takes some practice, but once you get that, it's very easy to create these layouts, and they are efficient because there is no hierarchy, right? So that's the idea here. Um, okay, yeah. So creating UI, no matter what layout you are using, as we know, can be done in one of the two ways. You can declare things in XML, or you can instantiate them in code. Declare things in XML, declaring things in XML is the preferred way because you have a separation of presentation from the behavior. It is also easier, because of the same reason, to provide alternate layouts for portrait versus landscape, as we have seen. Um, just imagine if you were to create everything in your Java code, you'll have to take care of screen resolution, screen sizes, placement of buttons, etc., in the Java code based on what orientation you are in. And that's just going to make it messy. Um, but if required, if there is a dynamic button that you want to show, for example, you could create it in the UI, sorry, in the Java code, and show it on the UI. So that is possible, but that is not the preferred way of doing things. Um, okay, so here is a little bit about constraint layout. I talked about most of it on that hierarchy slide already. Um, Let me just talk about this. Yeah, so the constraint layout, this is a quote from the Android developer page. Constraint layout allows you to create large and complex layouts with a flat view hierarchy, and you don't need nested view groups. So that is the key selling point of constraint layouts. Okay, so next we'll um, convert the dice game's wallet activity to constraint view and see how we can achieve the same UI using that.